Dave, good evening.
Hello,
All
Nayan.
right, so I think we'll let people join, but we'll start now. So the thing is that till now you've been all listening to me very patiently and quite a lot, I must say. And I know it can get overwhelming at times. So I thought of giving you a refreshing change today. So there's someone whose way of explaining the concepts I admire personally, and especially when it comes to one of the topics that we'll be covering today, which is DOE, the design of experiments. So I had the opportunity to attend one of her sessions on it, and I just loved it. So I requested her that if she can come in our session and explain it to everyone. So we have with us Dimple ma'am. Hello, ma'am.
Hello, everyone.
Thank you for joining this session today.
Thank you. Thank you for inviting me.
Yes, so guys, she'll be taking over today session, not completely, just the topic of design of experiments. And there are so many things about her which I would like to tell, but due to time constraints, I can just tell you that she is one of the best trainers I have ever met. Personally also and professionally also, she is a master black belt in Lean Six Sigma, and there are multiple certifications and degrees she is having, which you can find on her LinkedIn. So I'll not take you there because it might take a separate session. So handing it over to you, ma'am. Thank you.
Thank you. Thank you so much. So, I have two requests before I kick off. Some of you have named yourself as Dell, HP, and Xiaomi. So, I think your parents have put an effort in giving you beautiful names. So, please rename yourself. And I would love to keep your request you if you can keep your cameras on because then I can see your face. It's okay. You don't have to be in perfect uh, look don't have to do a makeup, but just keep your cameras on because that will keep me engaged. I will constantly get my oxygen to keep teaching you. Right? So wonderful. Thank you. Thank you, Monica, Abhishek. So I can see some of you have Atish, you have put on your cameras. Thank you. And others, Oppo, Xiaomi, and all, just rename yourself so that I can address you correctly whenever possible. Right? So you're all ready. I will try my best to keep you all entertained at the same time we do a learning. Uh, so just I would take you to something that's very important. She said, I'm going to teach you design of experiments, right? So why is it called as, any guess why is it called as design of experiments? What is experiments? Keep yourself, you're free to unmute yourself. What is experiments?
Via doing some practical things when we invent something that might be called an experiment.
Okay, very good. So are we experimenting with you all by giving you a new trainer today?
Yes, we are.
So, but if it's an experiment, sometimes when your friends are let's not even say friends. Sometimes mommy cooks a very nice dish, and she will give you. So you'll say, "Am I the guinea pig?" So you hesitantly try it out, right? Because it's something new. Yes, trials. So what do we say? Am I a guinea pig? Whenever there's an experiment, we don't want to become part of experiments. Yes or no? जब okay, when COVID happened, when the first test of vaccine was getting given, who wanted to become part of that experiment?
As a healthcare worker, we were there.
But that was mandated on you, right?
Yes.
Otherwise, your family members were telling, okay, Monica, if you can skip this, please skip it. Let few people be part of the experiment. And if the experiment is successful, then only we will want you to go for vaccine. And that's the reason Mr. Modi and all the other celebrities came up with a nice video which said that I am vaccinated. And that's where we felt, okay, if they are vaccinated, let us also do it. So whenever we think about experiments, it's a very nice word, as Sahil said. Okay, it is about trials, it is about experimenting, it is about trying it out. But internally, as humans with a human mindset, we feel I don't want to become part of experiments. Right? I don't want to become a guinea pig of the. I want to conduct experiments, but I don't want to be a subject of the experiments. Yes or no? And that's what we will take the first word of your DOE, that is design. So when an experiment is properly designed, then the chances of success is very high. And that is why it's not an experiment that I'm going to teach you, but we are designing an experiment towards an outcome. Right? So let's get started. You are able to see my screen?
Yes, yes.
Yes.
What's written over there?
Can I do it?
Can I do it? Okay. So I would request everybody to keep yourself unmute, remove the mute button from your mic. I'll get something on the screen and I want you to read it. Ready?
Yes.
Yeah.
Yes. Can you read it?
I could not believe that I could actually understand what
What
I was
reading.
reading, sorry.
The
The
phenomenal
phenomenal
power of the human mind.
according to the
According
research
to
of
research
Cambridge
of
University.
Cambridge
It doesn't matter in what way
order
or did the letter
in a word
was.
are. The
The only
only
important thing is
important thing
that
is
the
that
first and
the
the last
last
letter is the
letter
right place.
be in the
This
right
can be
place.
total mess and you can still read it without problem. This is because the human
The
mind
human
does
mind
not
does not
read
read every
every
letter by
letter by
itself.
itself, but the word as whole, amazing, yay. And I
I
always
always
thought
thought
sleeping was important.
Spelling was important.
Sorry, my bad.
spellings. It's
Spelling, yeah.
Yes. So during our school days, we used to get scoldings because our spellings were not correct, but you all are wonderful. You could read this with such a good speed, right? Even though everything was a mess. That's the beauty of a human mind, right? Why am I telling you the importance of a human mind? Why I was telling you the importance of experiments? Because understand, you are in the improve phase of your DMAC. What did you talk till now? Define. What is the problem? Measure. How big is the problem? Analyze. What is causing the problem? So we were talking about problem, problem, problem. Now you are in improve phase. You have to think about solution. When you're thinking about solution, even the toughest term like design of experiments, if you go out and tell your friends, oh, I learned design, oh, it's a very tough concept. No, it is not. I want to tell you that you are all capable of understanding even the complex topics, because if you can read a complete paragraph which is completely messy with full confidence and with the correct meaning, you will also understand the improve phase. And the important thing is, when you are going to design your solutions, you need to understand whatever changes you're getting to the process, where are you implementing that changes? You had a problem, you measured the problem, you analyzed the root cause of the problem. So now I need a solution. You found the solution. You would have done 5S, you would have done brainstorming, or you would have done design of experiments. Let's forget DOE. You would have found the solution by now, by learning whatever you have learned till now. Where are you going to implement that solution?
On the problem which we have found.
In the
Who's going to
process,
process, and who is working on the process?
stakeholders,
Who are the stakeholders?
team. Actually, it's a team which are experiencing it.
In short, they are humans, right? Because if it was a machine, you just had to replace one machine with another, right? But you are, whatever you are implementing, there is a human who is involved, and we need to leverage the human mind power whenever you're designing your experiments or you are designing any solution to your problem. So don't underestimate your team members, is what I wanted to tell you, that they can do anything and everything that you explain it to them, because human minds are amazing. And at the end, you are working with people, right? Because there is an Indian machine, you say, oh, I want a German technology, you order a machine, machine will come. Who will operate that machine? I get the Tesla's driverless car, but do you know that doesn't start on its own? There still needs a person in the driver's seat. Maybe that person doesn't know perfect driving, but it still needs a person in the driving seat. Do you know that?
No.
Yeah, so that's important. So whether Tesla is designing a car which is completely autonomous, it still needs a person to sit in the driver's seat, and then it will drive with confidence. So the best machine also needs human to work. So when you are designing your improve solutions in the improve phase, no matter whichever methodology you use, keep in mind that you are always thinking about solution from human point of view, right? So with that, let's get started. So design of experiment. So it is design and analysis of experiment, because it's not only about doing an experiment and forgetting it. You need to analyze, did this experiment work in our favor or did it not, right? What, y is a function of x. Do you remember that sentence? Y is a function of x. That's the whole purpose of your Lean Six Sigma, right? If I exercise more, what will happen to my weight?
You will cut the weight, you will lose the weight.
Yeah. If I eat a lot of sweets, what will happen to my sugar level?
There will be a spike in the sugar level.
Yes. So understand one thing. For every output that is happening, you always have an input. Right? So that's what is the y is a function of x. So your output is always influenced by input. If you think about pizza delivery, right? Domino's promises something. What do they promise?
30 minutes pizza delivery.
Yes. So delivery is the output which you are measuring in your project. Let's say the customer says you are not able to deliver pizza in 30 minutes. Domino's is not able to keep up the promise. What is causing that delay? There will be multiple input factors. Some of them will be controllable, some of them will be uncontrollable. Controllable, like, does the driver know the route? Is the pizza ready at the uh, franchisee by 15 minutes? Because 15 minutes he will take to deliver. These are all incontrollable factors. Today there's a very heavy rain outside. Is that controllable or is it out of control?
Uncontrollable.
Yes. So every process will have two types of factors, controllable and uncontrollable. We, in our experiments, will try to focus on what we can control. We will not try to control the clouds and the rain and the storm. We will try to control what is within us. We will ensure that we train our drivers well, we keep our kitchen intact, we have a proper order management system, and so on. So your input has multiple factors. So these are multiple inputs into your process. Controllable factors are what are going to become part of your DOA. So what happened before this session? Before today's session, what has happened? What did you do in analyze phase? You try to understand what is causing the problem. Yes?
Yes.
So you said the problem is caused because of, let's take the example of pizza only. Delivery time is delayed. So what is delivery time? It's your project Y. I want to ensure that Domino's is able to deliver pizza in less than 30 minutes. Right? What is causing the delay? So you did brainstorming exercise, you did your Gemba walk, you did data analysis, and you got to know that, do you know, first of all, pizza delivery is delayed. Are all the pizzas delayed? They said no. There are only 15 to 20% of the pizzas that are getting delayed. So we try to investigate what is causing the delay. So when you investigated, you did brainstorming Ishikawa diagram with your team. They said, do you know, veg pizzas are never delayed. Non-veg pizzas are delayed. So what is the factor? What is one of the input factor?
So non-veg pizzas
Non-veg
are
pizza.
taking more time in cooking.
Yeah. So type of pizza is a problem. Okay. Then the other person in my team, who was a subject matter expert, said, it's not about veg and non-veg. It is about extra toppings. Whenever the customer gives us extra topping requirement, we have to give special instruction, and that is why sometimes we get the pizza back and put the extra olives, extra jalapeno, extra paneer, etc. So extra topping is causing a delay. Then there is one more person who says, no, the driver doesn't know the route of Hyderabad. He doesn't know the route of Bombay. He has come from Chennai, he's familiar with the Chennai road, but he doesn't know this, and we have shifted him to Hyderabad or Mumbai, right? So experience of the driver becomes your X3. Then somebody says, the road is a problem. If the pizza request comes from this colony has gravel roads, it doesn't have a smooth road. So the last 200 meters also, the scooter doesn't go properly. So the type of road is a problem. So what is causing the delay in the pizza? Multiple factors, right? So we try to understand and we try to analyze what is causing, and we do the experiments. Now let's come to very simple. Whenever you do an experiment, there will be a small e. This is more from a concept point of view that you should know. There will be a little experimental error that will happen. It means that if you do the experiment, veg pizza with no extra toppings on a perfect road, will the pizza get delivered exactly at 28 minutes? The answer is yes or no. Because sometimes it can get delivered at 26 minutes, sometimes it can get delivered at 28 minutes, sometimes at 29.5. Right? Because they will be, why are these experimental errors happening? Why will the experimental error happen? Because
uncontrolled factors.
there will be some
Uncontrollable.
uncontrollable factor. Us din, there was Ganesh Visarjan going on. On that day, there is heavy rain. There will be something that goes on, and that will cause a slight delay. Everything being perfect, also some deviation in your output. Right? So if your stakeholder comes and says, so hi Rajiv, you have done this experiment. So you took a veg pizza, you took no extra topping, you took a person with experience in driving. The road was also perfect. Last time you delivered pizza in 25 minutes. This time for the same thing, you delivered the pizza in 28 minutes. Why 3 minutes extra? So you should say that is because of some external factor, and I'm not going to break my head over there. That is important. Is both 25 and 28 within your acceptable limit of 30 minutes? There are two important things when you do experiments. What are they? That you should ensure you plan the experiment very well, and you design your experiment very well, and whatever experiment you conduct, you have to do the data analysis correctly. So one is planning out the experiment and conducting the experiment. Two is that analyzing what we conducted, is it going towards our desired goal or not? Right? Because the best plan also, you might be the best statistician, you might have Minitab, you might have the best statistical analysis, including AI. If the planning is incorrect, everything goes for a toss. So don't focus on how Minitab will do the analysis for DOE. That is a 10 minutes job. What is going to take 2 weeks for you? Planning and conducting the experiment. So the whole purpose of the next 20 minutes is to explain how do you ensure that your DOE is successful, right? Because statistics part is a small part. The overall part is conducting the experiment. So these are the steps that we follow. We tell what exactly is the problem. Our project definition is there in your project charter, but you again try to tell everybody, do you know why we are doing this experiment? Because we want to ensure this happens. You are re-communicating the same. You would have multiple X's, multiple Z's, means you will have input variables, you will have multiple input, multiple output, one output variable. You will decide very clearly and communicate what is that we are trying to measure and what are the inputs that we want to make as part of my experiment. So even though you might have x1 to x10, you might decide I'm going to take 1, 3, and 7 for my analysis. Means I'm going to take type of pizza for my analysis. I'm going to take type of driver for my analysis. I'm going to talk about extra topics. Maybe you will decide based on multiple brainstorming sessions which you have done with your SMA or the previous analysis that you have done using 5i analysis or brainstorming and so on. Right? So what is the output we have to observe? And my inputs, in that there is something called as factors, levels, and range. I will explain that. You just need, there are a lot of terminologies which you will hear in the next 20 minutes. But all of them are very easy to remember. After 20 minutes, you'll remember all of it. Then you will select the experiment design. Not all experiments are same. Every experiment is designed with a purpose. So you will select which design works for me. You will perform the experiment. You will analyze the DOE and then give the recommendation. Are you with me till here? It's all theory till here. Right? So let's say I'm making steel spring. To make the steel spring, what are the input factors? So the SME says I need to set the temperature for the quenching. I can set it as 1450 or I can set it as 1600. Or because steel also has carbon, we have to focus on the carbon content in our steel. It can be 0.5% or it can be 0.7%. Now, who is giving me these numbers? Who is giving these numbers? SME will tell you. You don't have to break you all are black belts. You don't have to master the levels. You don't have to master whether it should be 1400 degrees or 1600 degrees or 1450. You go and ask your subject matter expert. You tell me what should be the best quenching temperature based on your 15-20 years of experiment. So he says, based on my 20 years of experiment, I can do 1450 or 1600. I can put carbon content at 0.5, 0.7. Temperature of the oil, 700 degrees Fahrenheit or 1200 Fahrenheit. Quality of requirement, this is my why. My requirement is when the steel spring comes out, it should not have any cracks. So tell me, for a spring without crack, how many items am I focusing on? 3. These 3 will become your factors. So if I go back to my thing, I said, right, the first term is factors. Factors are how many type of inputs am I going to study? There might be 20 other, but my SME is telling these 3 is only what is causing problem in my process. Output. Output, what do I want output? I don't want cracks.
Crack, right.
Yes, I don't want cracks. Right? So I don't want cracks. So there are 3 factors, 1, 2, and 3. Each factor can be set at how many levels? 1 is low, 1 is high, 1 is low, 1 is high, 1 is low, 1 is high. So 3 factors and 2 levels. Levels means settings. I can set the temperature at 1450 or 100. I can set the carbon content at 0.5 or 0.7. So how many factors do I have in this experiment? 3. And how many levels, how many settings are there for each of the factors?
2.
2 each.
2 each. So 3 factors, 2 levels, right? So you understood two terminologies from my previous slide, factors and levels, right? And that levels are having the range. That number again is given by SME. I don't have to break my head. I will ask the SME, you tell based on your experience. Now, what I do is, the SME says, my experience is 0.5 carbon content and 70 degrees Fahrenheit quenching oil is a perfect one. In that, let's do check for cracks by changing the temperature between 1450 and 1600. So he does 4. So what is happening? He's changing how many factors?
2
Yes. So, no, he's changing one factor at
at a
2
time.
levels.
Yep.
One factor at a time, but 2 levels he's testing. So he says, if I do this first sample, so he mixed all the ingredients, all the raw materials he has mixed. He puts in one machine line at 1450 degrees Fahrenheit. In the second machine line, he puts the same exact raw material at 1600 degrees Fahrenheit, and he finds that 72 pieces came out without crack, 78 pieces came out without crack. So in first sample, which is better? 1450 or 1600? Which level is better?
1600.
1600 is better. Then he goes ahead and mix one more batch after 2 days. He puts in the same machine in 50 and 1600. Here he gets 70 pieces without crack. Here he gets 77 pieces without crack. Then after 1 day again he does. He gets 75. Here he gets 78. After 1 day he again does. Here he gets 77. Here it getting 81. Everything others being constant, I'm only changing one factor. I'm doing it at a higher level. I'm doing it at a lower level. Now tell me, if you are running this experiment, which temperature is good for me to get crack-free springs?
1600.
1600.
Right? 1600. So good. You all are wonderful. You already know half of the DOE. Now one more SME comes and says 0.5, no, I want to check at 0.7 because I read in a research paper 0.7% of carbon will give me better results. So do you think I have to do the whole experiment again? This time I will keep, now 1600 I'll fix, but I'll change the carbon content to 0.5 and 0.7. Again, I will have to do day 1, day 2, day 3, day 4, and then count. Yes? Then one more person comes and says, no, we were talking about the other factor, right? The quenching oil at 700, it's not 700, it's 70 degrees Fahrenheit and 120 degrees Fahrenheit. So let's do that. Every experiment is going to cost you money, right? Because you are preparing a batch of raw material, you are putting it. Now, here's, let's assume 100 output were supposed to come, you got 72, here you got 78. What about the defects? And every day you are stopping your normal production and you are running experiments. Paisa kahan hai? Where is the money? Do you think your stakeholder will give you permission to keep doing experiment for 1 month, 2 months?
No.
No. So I have 3 factors and 2 levels. So he said, okay, 1600 degrees better at this carbon content and this oil temperature. But what happens if carbon is changed, or what happens to this? We don't know. So again, we will do 8 more experiments here, 8 more experiments there, and we'll die. So we'll have to do totally 24 experiments to get to understand those 3 variables. Let's assume each experiment is costing you 1 lakh rupees. So what happens at the end of 24 experiments? 24 lakhs gaya. What is the ROI on your project? Your boss will say, you stop your Lean Six Sigma. Let's do the business as it is. So we don't have to worry. There is something called as Fisher's experiment. He designed something called as a factorial design. He said, don't worry, I will not waste money of stakeholders. If you follow factorial design, we can do the same experiments with less number of trials. So what he does is he is designing this. Okay, so this is from annotation. Okay. So there are 8 experiments which you conduct and you're trying out. See what has happened to the temperature? Low, high, low, high, low, high, low, high. Right? So temperature, I have 4 settings, 4 runs, 4 trials, which I'm doing at low. I'm doing 4 trials, which I'm doing it at high. Now think about the car. Now, if you look at any experiment, you see that it does not have any repetition. 1450, 0.5 and 70 degrees Fahrenheit. 1450, 70, 0.7 carbon and 70 this. 1450, 0.5, 120. 1450, 0.7, 120. Are you seeing all the permutations and combinations? We are now able to do just with 8 runs instead of 24 runs. This is called as fractional factorial design. Why? Because instead of 24, I am doing now 1/3 of the experiment, still ensuring that all the possible combinations are taken care of. Do you feel I have missed anything? I have tried out. So you have high, low, and you have low, high, low, high, low, high, and then here you have the lows and the highs. So all the 3 factors at 2 levels can be solved using a fractional factorial design of 8 experiments. And they are also designing that on which day the experiment should run, and then you get your crack-free output. So in your mind, do you now understand how a DOE will work?
Yes.
From who is going to give you factors? Which factors to experiment with? Steel temperature, carbon content. Who gave me this?
The SME.
Exactly. And who is going to give you the levels?
SME will tell.
SME will tell. And who is going to give you the levels? SME.
SME will give factors and levels both.
Again,
Yes. So
SME.
don't take the pressure on yourself is very important, right?
Ma'am, so sorry to interrupt in between. Can you please go on the previous slide?
I'm here.
Okay. So like you have in the 3rd row, like where the run is still temperature, then after carbon and this O represent of
This is the oil temperature.
oil temperatures. Okay.
This is carbon,
So
this is oil, and this is steel temperature.
okay. So instead of like you have gone through 70, 70, 70, then after 120, 120, 120. So instead of taking from low to high, can we take from high to low?
Randomization will happen. This is more for you to easily understand. I have put it in a sequence. This dry run, here I said 1, 2, 2, 1, 2, 1, 2, 1, 1, 1, 2. This you will not decide. You will put it in Minitab. You will set the levels and all. I'll show you with the screenshots of how you do it.
Okay.
It will tell you in what sequence it has to go.
Okay. Thank you.
Right? So you can go from high to low, you can go from low to high, and you can completely randomize. Now, understand, imagine, can I do 1450 now and do 1600 after 2 hours? If I go to the manufacturing plant, they will kill me. They'll say, are you thinking it's a joke to increase the temperature and reduce the temperature? Again, after 1600, you are telling me to get it back to 1450. It takes minimum 2 hours to reduce the temperature. Right? So then we will give a constraint. One day we are going to do entirely of 1450 and one day we are going to do of 1600. Right? If it is a smaller thing, it's fine. But you need to understand the nuances, and that subject matter expert will tell you. Because it's not like my gas cylinder ke switch on kiya, off kiya. Right? If it's a big furnace working, think about Tata Steel. It's some million metric tons of production per day. And I'm telling 1450 degrees, it takes time to come to that temperature. After that, to increase by 150 degrees, again, it is going to take time. To reduce the temperature also is going to take 3 to 4 hours. And that is why these manufacturing plants, why do you think they work 365 days, 24/7? Because there are a lot of things which go on. It's not like my microwave or this that I press a button and it goes to the temperature, right? That is why the olden days ovens we are not using at home. It says preheat the oven at 200 degrees for 30 minutes. Nowadays we don't have time. That's why we are moving to instant things. So if you have constraint, you can do it. Otherwise, you can do it. Now, how did Fisher decide? Okay, instead of 24, if I do only 8, I will still get to understand all the factors, all the levels religiously. So what he did is, imagine this as a Rubik's Cube, right? So what he's telling is, think about carbon content as your side of the cube. So this side is carbon content. One side, the bottom of the cube is oil temperature. So the front is 70 degrees. The back is 1250, right? Carbon content, bottom is 0.5, top is 0.7. Steel temperature, left is 1450, right is 1600. So if you look at this, it will be an experiment because it's a 3-dimensional. You can have 4 factors, 2 levels also, but our human brain can only comprehend 3D things. We are not in capacity to see 4D, 5D images, but for our understanding, the 3 would be like a Rubik's Cube. The top and the bottom will tell you one factor. The sides of the cube is going to tell you the second factor. And the front and the back of the cube is going to tell you how the third factor results are coming. Right? So that is why you're getting 61. Now tell me which number is the highest in this Rubik's Cube. Because it is about the
90.
90. It is about the number of crack-free springs. So I got 90% crack-free springs at the right corner of my Rubik's Cube. Which means, what is my oil temperature? What was the back?
120 degree Fahrenheit.
Yes. And if I think about top versus bottom, what is carbon content? Up it is 0.7, down it is 0.5. So what is the carbon
0.5.
content?
0.5.
Yes, very good.
0.5.
0.5. Steel temperature, left is 1450, right is 1600. This is 90 is on right side, 59 is on left. So what is the temperature for steel?
1600.
1600. So out of all the factors and all the levels, these 3 factors at this level is going to give me the best results. So you are now confirming from your DOE that 1600 degrees with 0.5% carbon content and 120 degrees Fahrenheit of oil temperature is going to ensure that you get maximum number of crack-free results. Now, if you just go little up, what is this? 987, which is very close to 90. If I have to tell you, what are the levels of the factor over here?
Carbon content 0.7, temperature 1600.
Temperature is 1600, very good. And what is oil temperature?
120.
It will remain 120 because you are on this side of the cube. That side of the cube would be, the front of the cube would. So what does it mean? If 1600 is constant, 120 Fahrenheit is also constant. If my carbon content changes from 0.7 to 0.5, by 3% my cracks are still reducing. So out of all the 3 factors, which are the 2 more influential factors?
Carbon content is a major.
Carbon content is the major, or is it the oil temperature and the steel temperature?
Oh, it remains same now.
It is same on this side, but if this 1600, if I go here, this is 1450. Okay, let me just. Okay, so here you are sure both. This is 1250, 1600. Right? Sorry, my handwriting is really bad. This is 0.7, right? If carbon content was major, here also the carbon is 0.7. Why did it dip down to 52% crack free? 87 has become 52.
Temperature.
Temperature. So which is my more influencing factor? Is it carbon content or temperature?
Temperature.
Because
Temperature.
this 90 is becoming 59 just by reducing the temperature. So you, at least one thing I will tell my team for sure is, do not produce at 1450. Can I tell that sentence? Based on my
Definitely.
yes, right? So please do not produce at 1450. My results on this side of the cube are pathetic, right? But if you see 0.5 versus 0.7, 67 became 61, 79 became 75, 90 became 87, 59 became 52. It means carbon is also, if my carbon content increases by 0.2, what is happening to my cracks? They are also increasing. That is why crack frees are reducing. These are crack free numbers, right? So my cracks are is increasing by 0.2, my cracks are also increasing. Can I make that sentence?
Yes.
Because all the four side I could see when my cube is going up, my errors are also going up. So can I tell my team, let's fix 0.5 as my carbon content?
Yes.
Very good. Now let's think about front and back. 79 became 90. My crack free has moved from 79 to 90, has moved from 75 to 87. What was my oil temperature here and what is my oil temperature at the back?
70 in the front and 120 Fahrenheit, degree Fahrenheit back.
Yes. Why am I looking only on this side of the cube and why am I not looking at 67 and 59? When I'm exactly, you are all wonderful participants. So you understood, because I have already eliminated this, I'm not considering this side of my cube. Now I've focused only on the 1600, and within 1600, now I have 100% confidence which temperature for oil is best, which temperature for steel is best, and which carbon content is best. And this is not based on gut feelings. You guys have spent 8 runs of experiment to get to this conclusion. Are you all with me? Good. So,
Yeah, got it.
got it? So that is the same explanation over here. Now, let's do a actual experiment, which we can relate and you can recall after today's session also. We are going to make cake. When you buy a cake, what is the requirement you have? Should the cake be hard or soft?
Soft.
It has to be soft, right? Customers are complaining your cakes are not satisfying cakes. Either they are too sweet, they are too hard, they are not, we are not liking your cake. So you decide, we are the bakers, we want to do an experiment to find the best cake for our customer. So what are the ingredients for the cake? What are the ingredients for the cake?
Flour,
Milk, butter,
sugar,
flour, sugar,
sab-
egg, oven. Sorry, till
Yeah,
egg,
yeah.
till egg.
So egg, then you have oven, time, humidity, bakers,
other
right?
factors.
So some of them are your experimental factors which you want to change. Some are your control factors. Some are your noise factors. Your baker is a noise factor. Whether I bake or you bake, if the process is correct, should the baking happen correctly?
Yes.
Yes. So we are saying we are not going to consider baker telling that dimple is one and nine is another. No, these are noise factors. You are not going to evaluate this. So we are not going to study this. Now, within this, what is the thing that I can control? Can I control the oven, the time inside the oven and the humidity? Yes, I can do the setting. Right? Yes, Vinod.
I think oven is not only the problem. Uh,
No, it's not about
regarding
problem. I'm not talking about problem now. I will come to the problem later. The problem is the customers are not getting good cakes. The SME says, I need the raw material and I also need the equipment to make the cake. Okay.
but
And
what you mentioned about the ECM, those may be the part of the critical material attribute, critical process
yes,
parameter, as well as critical quality attribute. So
correct.
anything go wrong with these three elements uh, as compared to ECM.
Correct. You are 100% right. So I'm at step 1. I'm just formulating my problem. And my SMEs, what happens is when my brainstorm and my SMEs are giving me inputs, I will write down everything on the screen. Otherwise, people will not contribute. So if somebody said baker is a problem also, I wrote down the name of the baker. But then I said this is a noise factor. Okay. So we have listed down everything. We are saying what is the unit of measurement, what is the present status, what is the investigation range that we want to have, and are we going to have 2 levels or 3 levels, and remarks. So this is only a raw planning sheet we are filling up. Okay. Now we have taken everything, and after brainstorming, your team said eggs, butter, milk, flour, and sugar. These are the ingredients, and these ingredients is what is going to make the cake soft. Customer are satisfied, or this in something wrong over here, the customer will come. So here we have listed down all the 5 ingredients from my problem statement and listed it down over here, right? And currently today when we are making cake, we are using 2 eggs, 1 block of butter, 2 cups of milk, 1 big cup of flour, and 1 tablespoon of sugar. Example, I'm just telling, right? So today we are making cakes with this combination, right? Now, first step, we listed down the problem. Second step, we listed down everything that we are doing today. Third stage, we went to the ingredients and we listed down today, how am I making the cake? Now, the SME says, instead of 2 eggs, if you put 3 eggs, no, it will become soft. Instead of 1 butter, if you put 1.5 block of butter, it will become more tasty. Somebody said, no, milk. Instead of 2 cups of milk, if you add 3 cups of milk, it will be different. Flour, 1. Somebody said 2. Sugar, 1 and 2. So the SME gave me some inputs. He said this and this. Somebody said, no, if I have 1.5 block of butter, I need enough milk and egg to wipe it, otherwise it will not work. Now, so much of milk, I need extra flour. Otherwise, it will become pouring. So, SME gave me inputs. I have noted it down, telling that my first level is 2 eggs, second level is 3 eggs, 1 butter, 1.5 block of butter, 2 cups, 3 cups, 1 cup, 2 cup, 1 cup, 1 spoon, 2 spoon. Right? So, finally, we came to a conclusion. We are not going to worry about the oven temperature or the time inside. We will keep the same 200 degrees centigrade, same 30 minutes inside the oven, and any baker does it also, should not be a problem. Let us focus of our experiment on these 5 raw materials that go inside the egg. Keeping other things constant, raw material is what we are going to focus on. So we have decided how many factors? How many factors?
5.
5.
5. Very good. How many levels?
2.
Each 2, total
2
10.
levels.
Yes, each 2. So we
Each two.
always say 5 factors, 2 levels. So technically 2 raised to 5. How much is that?
32.
2 into 2 into 2, 5 times.
10.
32.
2 into 2, 4. 4 into 2.
32.
32.
32.
62.
32.
No.
32.
Let's take you back to the max class. That's my favorite. 2 into 2, 4.
4.
4 twos are 8.
8,
8 twos are
16 and
16.
32.
32.
I need to do 32 experiments to ensure all the 5 factors at different. So I need to do 2 eggs, 1 cup of butter, 1 stick of butter, 1.5 stick of butter. See, my first experiment. 2 eggs, 1 stick butter, 2 cups, 1 scoop, 1 spoon. Okay. My second experiment. Same egg, same butter, same milk, same flour, but 2 spoon of sugar. Second experiment. Now third experiment. 2 eggs, 1 stick of butter, 2 cups of milk, 1 scoop of flour. In the next one, I'll take 2 scoop of flour, keeping this constant. So I have to do all the permutations and combinations. I need 2 raised to 5, 32 experiments. I'm going to bake 32 cakes to decide which one cake my customer is going to like. What will the business owner tell me? Let's assume cost of making one cake is 1,000 rupees.
Throw us
32,000.
out.
He'll throw me out. So then we remember, oh, Mr. Fisher has taught us fractional factorial design. So let's understand that little better. So full is 2 raised to 5, 32 run, where I try to study A, B, C, D, E. That is my main effect. I'm trying to understand which is and I also try to understand the interaction effect, that if A and C will go together, what will happen? And if B and C will go together, what will happen? Somebody who bakes cake, do you know if egg and milk combination will change? 2 eggs and 2 cups of milk, the froth will be different. 2 eggs and 3 cups of milk, the froth will be different. 3 eggs and 2 cups of milk, it is different. 3 eggs and 3 cups of milk, it is different. So there is an interaction between egg and milk which will change the taste of the cake. Do you agree?
Yes.
Correct.
Now,
Yes.
somebody will say, think about butter and milk also. When butter, 1 stick of butter and 2 cup of milk, it has a little bit of soft moisture. 1.5 and 3, 1.5 and 2. So again the moisture. There is an interaction also happening, and there are so the main things have an effect, but 2 things combined also will have a different effect. The milk and the butter wiping will change the effect. So we want to study that also. So if I do 32 runs, I will understand all of this. So there is a concept called as degrees of freedom, means one factor is 1 degree of freedom. So A has 1, B is 2, C, D, E. A into B is 1 degree, B into C is 1. So totally, you are trying to study things from 7 dimensions. The cube had 3 dimensions. Now you have to study. So I can't show you a picture of it, but you have to visualize. So there will be a rhombus with A on one side up and down, B on one side up and down, C on one side, and then the joints of that rhombus will be like your diamond, Kohinoor diamond, right? So what we are going to do is, we are going to randomize the trial, minimum 1 trial per combination, and we will do this experiment. What are we going to evaluate our results on? We are going to taste the cake. We are going to look at the cake. The taste is very good, but the look is, it is all crumpy and all. Will anybody buy it? No. The moisture content, when I hold, is it soft enough? So there are 3 parameters on which my judges are going to evaluate the cake. They're going to give marks between 0 to 100. Higher the score, taste is better. Right? So they are going to do this experiment. How will they do? They don't have to run all the 32. If they run this 8, this is called as a fractional factorial design. All the combinations are actually studied. 1, 1, 1 means, what is 1? This is level 1, this is level 2. So when I write down A1, it means 2x. If I write down A2, means 3x. If I say C1, it means 2 cups. C2 means 3 cups. So you just have to remember this, or you keep it handy. You keep it on your notepad or your exam pad that you have, you carry this so you don't have to remember. So when you are doing this, A1 means how many x? 2x. A2 means 3x. So we are doing 4 experiment with 2x, 4 experiment with 3x. 2x, 1 butter, 2 milk, 1 flour, and 1 sugar. The next one, 2x, 1 butter, 3 cups of milk, 2 cups of flour, and 2 spoons of sugar. So this you don't have to worry. When you go to Minitab and you select fractional factorial design, this setting will automatically come, and the trial will also be randomized. Here, for your understanding, I kept as 1 to 8 in a sequential. In real life, it won't be sequential. You need to randomize. And that's why my first thing was randomize the trial to get the best results. Right? So I will do, instead of 32, with the fractional factorial design, I will I'll do 8 experiments. So only 8,000 rupees are going to understand what is the best combination of A, B, C, D, E. Now, the first factor, I got the score. Sorry, the first cake, I got the score. The second trial, I got the score. Third trial, I got the score. So in the score, what is my first thing? First is taste. 2 is appearance. And what is 3? The moisture content. So I need all of it, and I got the results. Now these results, you can see there are all numbers between 0 to 100. Now we conducted the experiment, 8 cakes, we tasted. Now we have to find out what is the optimal time. In the steel example, you had only 3 things. You immediately got an idea: 1200 degrees, 120 degrees, for 1600, etc., etc. Now I have 5. So what I will do is I'll use help of statistics. My objective is, at what level will I get the best score? Because in this case, higher the score, better the result. So I conduct the experiment and I get an ANOVA table which shows something like this. I'm not going to kill you by making you do the statistics part. Remember, I think you'll be able to relate to this example very well. I went for my full body checkup. When that report came, that report was 32 pages. When I get my full blood test, liver test, kidney test, and all those results, what is that I, as a person who got the test done?
So 90% things are within the range. Only in the 10% there is a variation.
Yes. And what do you want to see? Only those things where there's a variation. And if everything is within the range, the report will not have any red mark. Yes or no?
Yeah.
So first thing I do is I go to the last page and it says
Final
all the
interpretation.
parameters. So same thing you have to do over here. We have so many degrees of freedom. The error is this much, and so on, mean square and F ratio. There will be a next screen which will say the percentage contribution. You have to look at this. So it says, if you look, don't worry about all these. This is like my WBC count, RBC count, and some of the parameters which I don't understand. What I want to know is, which is the one which is having the highest number?
B.
B. What was the factor B?
Factor B. Butter.
Butter. So it says butter is an first influential factor in your cake taste. After that, it is D. Below butter was?
C.
Not C was
Flour.
something. I want to D
Flour,
was
flour,
flour.
flour.
So it is the quantity of the flour and the butter is going to take away almost 80% of your taste.
Taste.
So if you get that right, what is B into C? I told you, right? If you butter and milk, you are wiping together, it will change the SME said. When I explained you with my hand movement, you also got convinced. Yes, when you wipe the butter with the milk, the moisture content and the softness will change. What is my experiment telling? How much is the contribution of that interaction?
Not much of a change. It's very
It's 0. Yes. So it has actually turned out that it's a noise, and now I'm confident. Though the SME says, you don't know, you don't bake cake, Dimple. You are a statistician, you are a master black belt, you are not a baker. Milk and butter. Okay, you are right from your SME point of view. My statistics is telling that interaction is not affecting the taste. What should I focus on? The butter and the flour. I will fix most of the thing. And after that, the third thing is C. C is milk, right? Yeah. Now, so we understood what are the factors, but just like the way in that experiment, I also want to understand which level. So when you do that, you will get a result like this on Minitab. What we want is we want to find out that where my points are up, because in my results, higher is better, right? I said 0 to 100, higher score means better taste. So in milk at 1 and 2, which level is higher? Which score is higher?
1.
So milk has
One.
to be at level 1. What is level 1 in milk?
One cup.
1 cup.
Yeah. So whatever is there, you will refer to the table. You don't have to memorize it. Don't break your head for unnecessary thing. At butter, 1 and 2. Which one
Two.
is better?
2.
2, 1.5.
True.
1.5 stick. In flour, 1 and 2. Which is better?
1.
1.
1. In the interaction effect, for a interaction effect, it says, but if I go back, I'm not going to break my head on the interaction effect because AC is 4 and this. So BC, we are not even studying. AC, it is 4%. So if you want to understand the combination of A and C, it's telling A at level 1 is performing like this. So A, what is factor A? X. So if X are less, it is going up. If X, egg plus, sorry, what is this? I'm also forgetting. A and 2C. A is egg, C is milk, right? So it says for 2 eggs and milk, this is milk. So it's a combination, right? Egg and milk. So if eggs are 2, obviously level 2 is 3 eggs. Now tell me which level of eggs you have to take, 2 or 3?
2.
Which 2? Because it is, the score is higher. Now within that, milk is at 1 and milk is at 2. Which is up?
1.
So
1.
2 eggs with the first level of milk, whatever it was, 2 cups of milk. So here also 2 cups of milk is good, but 2 eggs with 2 cups of milk is giving me a better taste. So I'm understanding the interaction effect, the 4% contribution. Do you think I will study the B into C, that is butter into milk?
No.
Why? You are right in your answer, but why?
Very less
Because,
contribution.
because
Yes,
Very
milk
because
is
it's a
having a
noise.
less.
0.4 something contribution was there.
Dimple,
So
just one question. Are you going to teach us how to create the ANOVA table?
when you, if you want, we can do it, but it will be overkill because out of 100 projects that I have done, we did
Hmm.
DOE only in 2 projects.
Okay.
So don't over engineer. But if you are stuck, you have Nan's number and her contact details. When you are doing your DOE, we will help you out end to end. Don't worry.
Sure.
Right? What is, that's why I said, right? Statistics is only 10% part of it. What is it? Planning out the experiment correctly. And once you get the results, how to analyze that results.
Yeah, sure.
Right? And today we are in the world of AI. You dump the data, it will do the calculation. But when the calculation comes, you should know because AI also hallucinates. Okay, I should take the milk at first level, butter at second level, flour at 1 level, eggs at level 2. Means 2x level 1. Eggs at level 1, that is 2x. When the milk is also at the level 1. So I'm understanding all this. And what is the guarantee that your cake will improve? I will get a score of 81% because 81% of the contribution I'm studying. Now, so 10 cakes were baked, keeping optimum combination. So I got to know My first, I made 8 cakes. I tasted all the 8 cakes. I got the level. Now I know, take 2 cups of milk, 1.5 stick of butter, 1 cup of flour, and 2 eggs. Sugar, whatever you want to do, you do, because sugar is not at all influencing. What happened to the factor D? What is the contribution? It's almost negligible. That's why it's not showing up. Understood? And egg directly is not contributing. Egg is contributing in combination with milk. So we have fixed egg at 2. Sugar, now tell me, should you go with 1 spoon of sugar or 2 spoon of sugar when the contribution is not there?
Anything will work.
You should take
You
the
are a
One
cost
spoon,
cutting
1
expert
spoon will be fine.
now. Yes. Yes, because you are cost cutting expert also. 2 sugar means your cost is going up. So you high or low?
No.
How do you want your profits to be? So when things are not influencing, you will find that combination where your cost of production goes down. So suppose if egg was not influencing, then I would have taken 2x or 3x.
2 only.
Am I correct? Yes. So you don't forget the fundamentals that Nayan has taught you. Right? So we are focusing on cost cutting. If the factors are not influencing, I will go for the lesser quantity because cost of production will go down. So once I got the level, I made 10 cakes with exactly the same optimum combination. 2 eggs, 2 cups of milk, blah, blah, blah. Right? And then I got the results for those and I got to know, yes, everything is good. People are liking my cake and I got a score of 81 something. So you are now confident that you should be running your store with so many eggs, so much of milk and so on. And some of the factors are noise factors. So don't add more sugar because sugar is not a contributing factor. Right? So sometimes the SMA will come. Now let's think about the oven time and the baking time and the humidity. These are my process parameters. Should I have a gas oven or an electric oven? Should I bake for 45 minutes or should I bake for 40 minutes, 35 minutes? So people will again, SME will be there, na? He wants to keep his importance also. So then if you want, you can again run the experiment for that. Or you can include those also as part of your parameters. Like that was still 5. Now I have added is 6, 7, 8. In this case, I'm going for a robust design, means I still am doing only 7 experiments and ensuring that all the combinations are taken care of. Designing this experiment is a 2 minutes job using Minitab, so do not worry. My first question is, do I need to do a DOE? Then only get in there because DOE comes at a cost and money. It will not happen without it, right? Because you're going to experiment. So that's all from my end. Open for questions.
Hello.
Yeah, I can hear you.
Hello. Ma'am, I am having a question. Ma'am, do we need SMA to keep the other factors constant, or we will do it?
You are the coordinator of the experiment, right?
Okay.
So
Yeah.
you will ask him questions, and you remember when I was asking you guys question, I said your answer is right, but tell me why. You need to question your SMA in the same style. If he says, oh, I want more milk or more temperature for the steel furnace, why? Why do you think I should put the steel furnace at 1600? Because when you're changing it from 1450 to 1600, don't you think power consumption will go up?
Yes,
Right?
ma'am,
So
definitely.
you will ask those why questions first. And then once you are convinced, you will set the parameters, the factors, and then you'll set the levels. All the other things which are not part of your experiment, you tell them based on your experiment, let us fixed it at one level. So all the experiments in the first case happened at 40 minutes in the oven at electric gas oven, and it was at a humidity of 80%. Example I'm just telling. So you will keep everything constant, but you're still changing 4 to 5 factors. Right? Any other questions?
Okay.
Silence means either you have understood completely or you are completely lost.
I think definitely it's the first one.
Okay, so wonderful.
So thank you, ma'am. It was an amazing session, and I think others also enjoyed it. I'm sure they'll give me feedback once this session is over.
Thank you.
So
So
if anyone is not
thank
having,
you everyone, and thank you for actively participating.
Thank you, ma'am.
So much. Thank you so much. It was wonderful.
Thank you, ma'am. Thank you. Thank you, ma'am.
Thank you. Thank you. Have a wonderful day ahead. Bye-bye.
bye, ma'am. Thank you. Okay, so I think we should first take a break, and then we'll continue with the rest of the session. Sounds good?
Yes.
Yes.
All right. Okay, so
Yeah.
it's 9:45 currently, and we'll join back on 10.
Okay.
Thank you. Okay, everyone back? Shall we resume the session now? I hope everyone is back from the break. All right, so any feedbacks that you want to give me on the session that you attended with Dimple? Did you like it? Was it too much to handle? Did she make it easier for you? Anything that you want to share with me?
Was completely lost in that.
Okay, great. Wonderful. All right, so sir, back to your old basic trainer. I'll start sharing the screen. So since we have covered a very complicated topic today, we'll go to something very simple. All right, I have got one. She was
She
very
was
fast.
very sweet.
Oh,
Nice talking woman. She
I'll,
was very sweet.
I'll convey that to her. Thank you so much. So Vishal is saying that she was very fast and half of the lecture flown overhead. All right. Okay, got it. See, actually, the topic that she covered, design of experiment, if it would have been done by someone else, it would have been very complicated. She tried to simplify it to the bits and pieces to make it easier. But then I agree to it.
So
All
Neha,
right.
concepts are clear. However, I am just stuck on the how to create that table, ANOVA table particularly. Otherwise, concepts are absolutely clear.
All right, so it's very simple. If you want, if in any session we get 15 or 20 minutes to spare, I'll take you to
So,
Excel or Minitab, and then we can do a demo over there. It's like you just how you make the bar graphs and pie charts, as simple as that. So you just select the data and go to data analysis. So I'll run you through it once. Okay. So let's start with our session now. All right, so my screen visible to everyone?
Yes, sir. Okay, okay.
Great. Okay, okay, yes. All right. So to understand what Pokayoke is, we will ask a very simple question. What if we could design our systems so that mistakes simply could not happen, right? Which is preventing errors at the source. So actually, this is the promise what Pokayoke makes. So today you're going to see how this mindset transforms quality, not just by catching the errors after the process is done, but by preventing them before they occur. All right, just a second. Okay, let me. 1 second. Yeah. All right. So the basic meaning of Pokayoke is mistake proofing. So the principle is very simple of the Pokayoke. It is that rather than relying on perfect people, rather than expecting that people are going to be perfect, we create a process that prevents or maybe immediately reveal the mistakes or even doesn't even let that happen. All right, let's understand this with some very simple example that we see all the day in our lives, but we just don't know that this is Pokayoke. All right, I've mentioned this so many times in my session that Lean Six Sigma is all over in the world, all around us. We just don't give that thought to that particular process or the product that this is designed that way, right? So, for example, this. All right, this is something we all have used. Yeah, so this is your phone's SIM card. Now notice the SIM tray and the design of the SIM card. You notice there is a cut on one corner of the SIM card, and the same cut is on the tray. So it only fits one way. If you try to put it upside down or the wrong way, it simply won't go in. So that is mistake proofing. So the design itself prevents you from making an error, right? Similarly, we have another example, this. Now tell me, even if you are not someone who is friendly with the process in which maybe this tool was being used, you can easily tell that first the screw will go. Why? Because you can already see that here we have number 1 written. Second, we will go this because it is in the tray where number 2 is written. And third will go this bolt because number 3 is written here. So this is a very simple assembly example. Now, workers often deal with dozens of small parts when they are working in a factory or in a process. Now, if the wrong part gets fitted first, or maybe they forget to fit one part, the whole product may fail. So this simple tray with numbers for each part ensures that only the correct component fit on the right slot. Again, the design makes error nearly impossible to do. Even if someone skips and forgets to put this visor after the process is done, they'll know that, oh, the visor in the second tray is still there. That means I forgot to put it into the process, right? All right. Next we have, wait. Okay, very simple question. Tell me, what do you think is the, which one do you think is the right key for this lock?
With red marking.
Red one.
Why do you, how do you know? Do you own this lock? Has anyone told you before that this is the key? How do you know that this is the right key for that lock?
The lock is
Because it has the marking on that
mark of
key.
red.
Correct, correct. This mark is telling you that this is the key for this lock. So out of the 6 keys here, only one works. And you know which one it is because of the marking. This is simple Poka-yoke, right? So the product itself tells you instantly that you are doing it wrong. So if you're picking up any other key, the product itself will tell you, oh, this is the correct answer. Here I am. Pick me up, right? So that is Poka-yoke error prevention built into the designing itself, right? So whether it's your phone, whether it's a factory assembly line, or whether it's just normal life, Poka-yoke is everywhere, and you will know when you see the products. Now, so the goal of mistake proofing is to design products or process in such a way that users don't have to stop. They don't have to stop and think about how to use them correctly. Did you even took another second to find out which is the correct key? No, right? Because it is already implemented by Poka-yoke. Now, the design itself here is preventing any kind of misuse. So even if someone tries to use it incorrectly, it simply won't work, right? Making the error immediately clear, making the error impossible to happen. So these smart, small designed features reduces the chances of mistakes and makes correct use almost automatic. Like it is not you are forced to do that thing. It becomes like a habit, like something which is happening automatically. So the idea of mistake proofing was born from the need to ensure quality in manufacturing, just like any other concepts that we read in Lean Six Sigma, other things we covered. So this is Shigeo Shingo, one of the key architects of the Toyota Production System, the TPS. He introduced this concept. He was a very renowned quality thinker. He championed the philosophy of zero defects in the industry. It is because of him that we know about this concept also. And he made sure that zero defect is a new standard for excellence. It didn't exist before him. So his approach emphasized that processes should be designed to detect and prevent, or rather, I should say, prevent and detect errors before they happen, right? Which also ensures that the outcomes of any process or products are of highest quality level. All right. Okay. Now, let's connect this concept to everyday life, the things we see in daily life. So, mistake proofing is all around us, as I said, though we often take it for granted, but it is all around us. Now, tell me, what is this? What do you see? What is this?
Gear.
Gear.
Yeah. Yes. Now, tell me, for people who know how to drive a car, can you turn on the car, just like turn on the key of the car, and if you shift the gears, will the car start?
Different cars have different features. Some go with the clutch with key start,
Mhm.
and some may start automatic. There are automatic.
Yeah, if we are not talking about, even if an automatic car, but let's not go to automatic. Even if I talk about the manual cars, so a car won't simply start if you will turn on, or if you will just start moving the gear stick. It
Yes.
simply won't start unless
Yes.
the gear is in neutral position and
Yes.
the clutch is pressed. So that is not just a safety feature. It is Pokayoke. So it prevents any kind of accidents or damage to the users. So it is designed to stop us from making any dangerous mistake, because many times it might happen that the gear stick, just with a sudden push, it changes. Even if you want to change the gear, you need to push the clutch pedal. Okay, let's move to the second very simple example. A microwave. We all have this in our homes, a very common appliances, kitchen appliance. Now, no matter how much you press the button, it won't run until the door is fully closed. Why it is there? This is also Pokayoke. That's Pokayoke for preventing accidents again. And of course, the next example, which is the most simplest, is the USB connector. Now, love it or hate it, but it only goes in the port in one way. That is also Pokayoke. Now, the design that forces you to connect, to push it inside only the correct way. Still, we sometimes make mistake and try to toggle it this and that way. But this design on this side of the USB port, if it matches the design on this, it means you're inserting it correct, right? Now, let's shift to industry. So, at Toyota, on the assembly line, workers often forget to insert a tiny spring inside a switch that they were manufacturing. If missed, the whole switch would fail later. So, what the engineers did, instead of blaming workers for not paying attention on or saying them, "Oh my God, how can you do such stupid mistake? Are you not trained enough? I think we should change the workers." Instead of doing this thing, Toyota engineers redesigned the workstation. What they did, they added a very simple tray with placeholders for each spring, like we saw in the first slide. So if any spring was still left in the tray after the assembly, it was immediately clear. It was obvious that something had been missing, something had been missed while the process was being done. So it was not at all a complex technology. It was not huge cost, just a very simple visual cue for the workers to find out that they have made a mistake, or how they can prevent from making that mistake. So it eliminated that problem permanently from the system. So this is the essence of Pokayoke. So don't rely on people being perfect. Don't expect them to be perfect, because then we all know to err is human. But design the process so that the errors either just cannot happen. Even if they do, they are immediately visible. Either we get some visible cues or some kind of alarming system so that it is there. Now, this mindset is actually what propelled Toyota to world-class quality, for which it is known worldwide. Okay. Now, let's understand what are the types of Pokayoke that we have. Okay, so Pokayoke isn't one size which fits all. It actually has three types. The first one is control. Now, this means the process simply cannot continue unless the right condition is met. Like we saw in our manual car gear example. Now, imagine another example which is very handy and we have seen it multiple times. Here also we all have different kind of locks in our home, but this is, I think, the most common one. We have seen it somewhere or another. Now, imagine this interlock on your door. Now, you cannot remove the key from this lock unless the door is locked or fully closed. So that is control Pokayoke. It prevents you from moving forward until the step is done correctly. Okay. Now, the second is warning or detection. Here, the system doesn't stop you, but it alerts you when something is wrong. So this is a very common example. So the moment this is the seat belt alarm, right? So the seat belt alarm in your car. So you can technically drive without fastening your belt. You can do that. Like, it's not a problem. But the car keeps beeping until you fix it, because that is how the system is developed for the safety of the user. So that constant nudge is Pokayoke, right? Now, the third one, which is also very common, we have seen it multiple times, right? What is this? This is the third type, information or confirmation. Now, this one is about double checks and confirmation. For example, when a website asks you re-enter your new password before saving it into the system. So it is not stopping you from changing the password. There is no ulterior motive for them to stop you or ask you again that whether you're sure of changing your password or not. It is making sure that you have entered it correctly, because many times it happens that while typing, we want to press C. By mistake, we have pressed O. So if I want to write my password as parrot, by mistake, I could have written it as orat. Right? So to prevent this, it asks us to re-enter the password. So this is also Pokayoke because this reduces the chance of error. Okay. Now, the question is, we know what is Pokayoke by now. We know the types of Pokayoke. But the question is how. So the rules for this are as simple as the name. I really like the name. I think it's very cute. So the rules are very simple, but yet it is very powerful. So first, keep it simple. The more complicated it is, the higher the chances that it will fail, because we want it to be like salt. How salt dissolves in any dish or in water, so we can get the taste of the salt, but we cannot see whether it is there or not, right? So we want our Poka to be as simple as it. So it just gets adapted in the process like a natural thing. Second is know right away if something is wrong, because that is how you develop any strong product or any strong segment. So that is very important that you work on the feedback. Third is design with the operators in the mind. Who is going to use that Poka that you have developed? So if a Poka slows them down or frustrates them, guess what? They are definitely going to bypass it, right? Because for them, it is useless. It is not fastening their process. It is not making it easier for them. So for them, it is useless. And if not monitored all the time, they are going to bypass it. So for example, the charging port of our phones. Does Apple guys or does the Samsung people come to you every day and tell you ki, put your charger in this way or put your charger right here only? No, they don't, because they have performed Poka there. So they are not worried that they have to go to every user and tell them how to put charger on your phone, right? Okay. Because they have kept the operators in the mind. Okay. Next is pilot before you fully roll out it. Now, we already understood what is the importance of pilot yesterday. So this also requires pilot testing. So test Poka also in small settings. Then you refine it. And if things work, we can scale it later. So the best Pokayokes are almost invisible, as I told you. So people don't even notice them after a while. But they quietly drive massive impact on quality, on safety, on process improvement, right? And that is, I think, what is the magic of Pokayoke. So any questions in Pokayoke till now? Because after this, we are going to do an exercise. So if any questions are there in Pokayoke, please let me know. None? Yes, washing machine door is also Pokayoke. So if you have seen the dryer, the tumbler of a washing machine, if the what do we call it? The ढक्कन of the machine is open, the spinner will automatically come to a stop. No matter how fast it is spinning, a second before you open the gate of that spinner, it automatically will come to a stop. And this is to prevent from people's hand into getting trapped into it. So yes, that is also a daily life Pokayoke. Wonderful. Thank you, Vishal. Okay, so now we are going to do one exercise. All right. Now we are going to design a Pokayoke. Imagine that you are running a bottle filling line. And sometimes the bottles leave without the caps on. These caps in the bottle. Okay. Now, what is your task here? You understood the problem statement? Everyone, please mention the chat box or maybe unmute yourself and tell me, is the problem statement clear? What the problem is happening?
Yes.
All right, great. So now what you have to do? What is your task? It is to design a low-cost Pokayoke to prevent that from happening. Now, use your creativity. It could be mechanical, it could be visual, it could be digital, it could be anything. So I'm going to give you 15 minutes in groups. So I'll put you in breakout rooms and then you will be presenting your solution. And the only rule is that keep it practical. Think about the users, the operators, make it effective. Try to make it user friendly and try to make it invisible. Like after few days the users will forget that they have implemented something, but the effect, the impact is still going to be there. So now I will put you into breakout rooms, and it is mandatory for everyone to give their inputs and then present it. So you can use anything. You can use a paint file like Word to design anything that you want to do, right? So I'm going to stop the share for a second. And I'll start putting you in the breakout room. All right. So the time for this exercise we have is 15 minutes. So we are starting at 10:25. So make sure you are keeping track of time also. Okay. Okay. So we have 25 participants. So we are going to create 5 breakout rooms. Okay.
Sorry if someone is speaking, couldn't hear anyone.
So we just got back into the main room from the breakout room, and I'm waiting for others to come back because it gives 60 seconds to come back to everyone. So as soon as everyone is in the room, we'll start sharing the responses.
Noted, noted.
Yes. All right, so I think everyone is back from the breakout rooms. So who would like to go first with the first? I think let's start with the room one. Who all were there in room one, and who would like to present the idea they got? All right, who would like to go first?
Oh, we can go, Nayan, with
All
our
right,
ideas.
great.
Okay, so Bharat have shared an idea that we can install the vision detection system.
Okay.
And I have given the idea that we can use a small sensor which can detect height and weight of the bottle. Because see, if we are capping that, again, the height and the weight can be detected. Correct. And that conveyor can move that bottle to the next unpacked thing. So these are what we idea we have got.
Wonderful, wonderful. How you think, was it very difficult to reach to this analysis?
It was not difficult. If we can see, like we have taken this, and one more thing, that we can pass through one sense scanners. These are the three ideas. So we have taken that from the publicly what is being used. Like see, when we are going through a metro station, we keep our luggage and it get scanned that there is no metal detection, something like that. So one of the idea we have got from there that we can put the bottles in that scanner and anything mishappen like uncapped, it's not filled properly, the labeling, so we can move that bottle apart from the good one. So we have get
Which I gave you was only about the uncapped bottles, but while finding solutions, you also found solution for other problems that business face. So great. So apart
sorry,
from
Nan.
that,
This was not my idea. I think this was Abhishek or some other's
your
idea.
team, I
Yeah,
meant your team.
room
Yes.
three, room three. Yeah.
Yes, room three. So wonderful work, room three. Great. Okay, so Vishal has shared idea of their team in the chat box. So the first idea which they have is we can install contact probes. That is, a physical probe can be designed to detect the presence or absence of a cap as the bottle passes by. If the probe fails to make contact with the cap, it signals an error, or even with interlocking, we can stop the line as well. Wow, very high tech and technical, amazing. We can have a vision camera. So I think it is same as we just heard from Sahil. We can have a vision camera. If camera captures the color of the cap, then okay, or else the line stops. Third, we can print the date of packing or some information on the cap face. So if there is no cap, that information is not printed. Wow. So see, they have also resolved two problems in one solution. So wonderful. All right. Who else? Fourth, we can set a
Yeah.
diversion system. Sorry?
Yes, you can talk.
We can set a diversion system with prober sensor as well. That is, if uncapped bottle identified, then that system will operate a pneumatic arm and to separate the bottle from the bottling line. Wonderful. I think great work by this team also. All right. Who would like to go next here?
There is
So,
a room
Nayan, what
for
is our idea? That according to the length of the bottle, if
Hmm.
the cap is not there, we will put the sensor.
Hmm.
If cap is not there, immediately the red, light will open and alarm is there.
Right.
So the person who is working on that project, he will immediately remove that bottle.
Wonderful.
Otherwise, green light will go and it will go for the packaging.
Great. So you are also using the second type of Poka we learned along with the first one. Great.
So Nayan, I think first we can put a sensor at the time of capping of the bottle. So there is a sensor in the bottle capping machine. So no bottle will be left without capping. And
Okay.
even after that left, there is a conveyor belt. There must be an alarm, or there is a separate passage for those bottles which are not capped properly. So they will go on that side, and the capped bottle will go on the right side. And third was given is the basically at the time of sealing. When the bottle will be sealed, if there is no capping, the sealing process will also not
Happen.
happen
Mm.
actually. So, and these
So,
are the three things we.
right. So the beautiful thing about your all the solutions is that you thought out of the box. So when everyone was thinking how to separate the uncapped bottle from the line, you put Pokayoke in the caps itself, so this problem doesn't even happen. So I think that is a very amazing thing I like about your solutions. So wonderful work by your team also.
We can say the detection must be automated. With the FMEA, there is a term detection. So that detection could be automated so that
Yes, it
this
can be
could be
automized. Yes,
the problem.
correct. All right, so I have another message. So there's another idea. If the cap is not picked to put to the bottle, then itself the line stops. Yes, Shravan, we can do that also. But stopping the line every time will be of hassle to the operators also. And the primary focus of Pokayoke is on making it simple for the user so the process doesn't get affected. So stopping the line, if you're in manufacturing or if you have ever worked in a manufacturing plant, you'll understand what is the cost of stopping the line. Then the alarm can use up. Yes, of course. Then alarm can work. Wonderful. All right. Anyone else want to share their answers, or should we move ahead? All right. So let's go to the last topic that we have now. Just give me 1 second. So I think after a very complicated topic, Pocoyo have worked as a sprinkler in your brains. Okay. So all of you have done this activity very nicely. Okay. Now we will go to our next topic. Okay. So now we have completed Pokayoke. We have completed pilot testing. We all know how to do a pilot testing. We have understood the design of experiments, how to get the perfect balance, and how to get the right product mix, or get the what should I say, the standard thing to follow. But now, the do we take a successful improvement and make it stick? So we know that this XYZ product or this XYZ process, if implemented successfully, it worked out well for us in our pilot movement, and make it stick throughout the processes, throughout the organization, or throughout the sector that we are in, and spread it across the organization, but also make it work. So it is not mandatory that if it had worked in pilot, it would work it everywhere. So you understood the X and Y's in the design of experiments, that how some are controlled and how some are not. Because let's face it, a great pilot is very exciting. But if it stays locked inside one team, one department, it is just like a shiny success story. It is just like a story. But it will not become transformation until unless it travels the journey from that one department to the whole organization. So scaling is where the real impact happens. Now, think of it like, so yesterday we were talking about how your mother tries a recipe first with you. All right. Now, but if she doesn't give it to the guest on the Diwali for which she was originally planning it, will it be called a successful scaling of that pilot project? No, right? So think of it like discovering a perfect recipe. You have mastered it at home. It tastes amazing. But now imagine that you own 50 restaurants and you want every single branch to serve that same dish with the same quality, with the same taste, and that too every single day. That is what is called as scaling. So it is not just about replicating it same, but it is about systemizing so the process is excellent every time, every day. Okay. Okay. Now there are few steps which you need to follow. I think there is a message in the box. All right. So these are the steps which you need. First, understand what worked and why. Very simple. So just give me one simple answer. Suppose my daughter is all grown up and I just told you I'm just very happy today, and I just came to the session and told you that I'm very happy today my daughter got selected in IIT. What is going to be your first reaction?
We will be happy about that and we will
Okay.
congrats you.
Okay, and after that, what you are going to do? What is
With
going to be the
IIT.
question?
Which IIT, what, how much she scored,
Okay,
Branch.
and okay, and what is going to be important question if you have
how she is feeling right now.
okay, and after that,
Which
How
coach?
she achieved,
how she achieved
what she
it, right? What worked out for her? Why will you ask that question? Because you would try to understand what worked out for her and how you can replicate it, how you can make your kids do it, or someone you know of that age do it. Ki, "Arey, I know that person and her daughter got selected in IIT and she did this, she went to this coaching, she read this books." So why we want to know those things from a success story so that we can, and can we replicate it or not? All right. So in pilot, success is often a mix of process. It is a mix of people. It is a mix of tools, so many things. But we need to distill what really made the difference, what really worked out for them. What is the method? Who were the owners, who were drivers, or was there some new tool that they were using that worked out well for them? Because without this clarity, scaling becomes a copy paste but with guesswork. Okay. Second is codifying the learning. All right. Now, what do we understand by codifying the learning? Codifying the learning means whatever crux we got in step one, we codify it. So it is easier for people to replicate. The people in our process, it is easier for them to replicate it. Now, this is where the knowledge, we turn the knowledge into explicit system. Now, what could be the systems here? It could be SOPs, it could be templates, it could be visual boards, cue boards, training guides, and so on. So these things make success repeatable, copyable as per your circumstances. It also makes it easy for them to transfer it. Now think of it as packaging the recipe so anyone can follow it, right? Let me give an example for this. So McDonald's doesn't rely on any one great chef, right? Like any other restaurants which are also very famous. What is the thing that they rely on the chefs? Their level is set that we want a chef of this much experience and all that thing. But have you ever seen any great chef working in McDonald's? No, right? They have codified how to flip a burger. Even that has been scripted. Even that has been manually put there. How to set the fryer times and even the salt fries, everything is the things are set there. It has been standardized. So the Big Mac or any of the burgers, the Mexican burger, anything, it tastes the same every time. Whether you order it in Tokyo, whether you order it in London, whether you order it in Indore, the taste is going to be same everywhere. Right? Now, the third is test in new context. Now let's understand why this is so important. Because scaling is not about one giant leap that, okay, we got successful in the pilot test. Now let's jump and take over the whole world. No, it doesn't work that way. It is a series of small steps again. Even after pilot, we'll have to take small steps. So we take the improvements to new team, we take it to new regions, we take it to new product lines, and so on. What are we doing here? We are adapting, we are observing, and then we are refining. Because we are not just doing copy paste and scaling, we are also putting conscious thoughts as per the changing factors in the situation. So, if you try a dish for the first time, so everyone is skeptical that we are trying the dish for the first time. We're not sure how it is going to taste. So what we do, you don't eat the big bite at that time. What you do, we just taste a little to get to know what is the taste of it. Now, if you like the taste, what you do? You don't eat the whole plate in one gulp. After that, also, even you are sure that I like the taste of this dish. Even after that, you are taking small bites. So, just like that, scaling works the same way. Expand in small bites, not just take a whole giant swallow. Next, we have build capability. So, I've seen many projects fail because of this particular, because this particular step has been missed there. Scaling fails when people are just told copy paste. They're just told, I am telling you to do this, just copy this. We need to train, we need to coach, and we need to support people. Even in McDonald's, Domino's, or any of the chains, does people just come and start working in the kitchen because they are sure that we have got the SOPs hanging from the wall, we have got the visual chart of how to make a pizza? Is it possible that without even any training, if person follows that, they can make the exact pizza or the burger? Team needs a safety net, a space to learn, a space to practice, a space to gain confidence. Otherwise, the improvement collapses. When the pressure comes, all these improvement, all the other steps that you have been working on will collapse. So, like, think about teaching your kid how to ride a bicycle, or any child if you don't have a kid. So you don't just say, ki, watch me how I'm doing the pedals and how I'm cycling, and just copy it. Do you say that? And do you think even if you say that, the kid is going to learn how to ride a bicycle? No, right? So you give them training wheels first, then you hold the seat for them till few steps. You encourage them, ki, yes, come on, you can do it. You are going good. It is fine. And then slowly you let them go. So that is capability building in simple terms. Next, we have monitor relentlessly. Now, as the name suggests, how we can monitor processes and actions. There are many tools, like we have got dashboards, we have got control charts. If we talk about service industry, we have got KPIs. So these are our early warning systems. right? So actually they help us spot the drift before it becomes a decline. So in any process, first there is a drift. People start slowly with the drift, and if it is not noticed, if it gets unnoticed, then it turns into a total 90-degree decline. So scaling isn't just set the process and forget, just chill and watch Netflix. No, it is scale and sustain. So it is going to turn into a successful story only when it is sustaining. So now think of fitness journey, for example. So you don't just start exercising and forget about it, right? You also track your weight, you track your stamina, you track your steps that you're taking, you track what calories intake you are doing, right? So we go haywire when we are trying to lose weight. So because you know that if you don't monitor, you won't know whether you're progressing, you won't get the motivation of doing it, and thus you'll be slipping back to the same old habits. So scaling improvements in business works the same way. You need regular checks to make sure that the results are sustaining. The last we have is celebrate and communicate, which is very important. So we tell the story, we share the wins, we spotlight champions. Why we do that? Because scaling is as much about energy and belief as much it is about system. It is not always just the data and Excel sheets, right? So such stories create momentum in the team, and that momentum actually fuels the adoption, because people go crazy when we ask them to change something. Even a slightest of change makes people uncomfortable. And that is why such momentum is required, so that they turn that confusion into something which is more optimistic. So now this is the last slide. I think it's, yes, the time is also up. So I just quickly wrap it up in 5 minutes. So just with me for 5 more minutes, okay? The pitfalls and the culture. First one is no ownership beyond pilot team. Often the pilot team is very excited, it is very passionate and very invested. But when the time comes to hand over it to other team, like Sas and Bahu. So at the time of the marriage of the son, the mother-in-law is very excited, very passionate. I'm going to do this, I'm going to do that. But when the time of handing over the tijori ki chabi comes, is she equally passionate? She's not, right? So similarly, here also, the improvement will come only when their project, like from the team of the pilot, it is the project of the pilot team will turn into the project of the organization, right? So if it is not working like that, that is the fastest way to kill the momentum. So it is the biggest pitfall which should be avoided at any cost, and the transition should be very smooth, right? Second, we have poor documentation. So improvements, if are not clearly documented in the form of SOPs, in the form of training guides, in the form of checklists, then when other teams try to replicate, they reinvent the wheel, right? They are going to make mistakes, they are going to blame the method, they are going to blame the documentation, and they are going to blame it on the pilot team. So it is very that poor documentation should be avoided, because there is a kahawat in Hindi which says "100 baka ek likha," which means even if you're telling someone anything 100 times, they're not going to understand it. But if you write it only for the one time, it will go straight into their brains. Third is scaling too fast. So sometimes leaders see a quick win and want to roll it out everywhere tomorrow, because come on, who doesn't want to make quick money, right? But without considering difference in the context, like customer base, shift patterns, resources, or any other uh, contexts which are relevant, the rollout is going to fail. It's like planting mango trees in a desert just because they grew in the garden. So if the mangoes are, if the tree is giving you mango when it is planted in your garden, does that mean it will also give you mangoes when it is planted in the desert? No, right? Because the circumstances, the context has completely changed. So we did the pilot when the mango tree was in the garden, but we didn't do it when it was in the desert. So we have to make sure that context, difference in the context are also given equal importance here. Next, we have ignoring looks. So every site, every branch or team has its own realities. So a solution that works in one environment may clash with another. If you don't adapt to the local context, people will resist and the improvement is going to stall. So a very general example for this. So in Ahmedabad, the quantities of Jain people is very high. So many food chains were launched there, but they didn't survive because they didn't have Jain food options like McDonald's or Domino's. But later, only for that particular city, they introduced Jain menus. So what they did, they did not ignore the local context, and as a result, the chains are thriving there also. So we understood what are the pitfalls which should be avoided to make the scaling work well. Now let's understand what are the success drivers. First is empowered teams, because scaling succeeds when team are not just told what to do, but they are also empowered to own the improvement. Right? When give them training, give them resources, give them decision making power, the ability, the confidence that yes, you are the owner of this process and you can make the decisions, right? Second is internal champions. So every rollout needs local heroes, people inside the system who believe in the change and stand up for it, advocate for it. These champions actually drive the adoption for then top-down orders. So it is important that there are internal champions. Then third, we have shared stories. Now, understand one thing. The data that you're presenting is going to convince the head, but the stories win the heart. So when teams share success stories, this new process cut out rework into half. So others want to replicate by their own. Now understand, in a meeting, if I'm telling people that this is the percentage of the cost we have reduced, this is the percent of packing waste we have reduced, this is the number of profit that we have increased. This is all the data that I'm giving, and it is looking very pleasant to my brain. But the moment I say that I put this out all is form, my heart is going to get connected to it, and other people will also get automatically pulled towards it. That we can also do that. Let's do that. Let's not show resistance to this change. Instead, let's do it in more better way than they have done it. Right. Last is the continuous feedback. So scaling is not a one-way road. It is actually like a loop. Teams need a way to give feedback, adapt, and refine as they adopt to the change. You cannot force someone to do something. So feedback keeps the improvement alive. It keeps them evolving, and so they are flexible and they are not just rigid and brittle, because that also brings people to make it less rigid and brittle and make this transition better and smoother. It is very important that you are in process of taking continuous feedback from your team. So remember that scaling is not just about spreading a solution, it is about spreading ownership, belief, adaptability, and such skills. So if you avoid the pitfalls that we just discussed and embrace the success, the drivers of the success, your improvement will not just live in the organization, but it is also going to sustain without even someone monitoring it continuously. All right. So I think that was all about today's session. If you have any doubts, please let me know. Anyone, any doubt? Either you all are asleep or you have no doubt because it's already 11:10. No doubt. All right. Okay. Thank you, everyone. Can you explain scaling in single line? So explaining in single line will be that once the pilot is successful and you want to roll out throughout the organization, you go to scaling, and by following the steps that I just told you, you can scale that successful implemented pilot into the across the organization. This is scaling. All right, everyone. Thank you so much for being such a lovely audience. I really like it when you guys interact because that's how I get motivated. So thank you very much. I'll see you on next Saturday. Bye bye.
Thank you, ma'am. Good
Thank
night.
you. Good night.